Good evening, folks. Can you hear me okay? Here's the first question. If you can hear me, leave something in the chat window. That would be really useful. So I know the audio is working okay. Awesome. Perfect. Right. Let's get cracking. Okay. So the plan going forward is, can you hear this one here? That's not in the right place. Let me just. Can you hear the audio all right? Is it loud enough? It's not really showing up on the screen. Let me know before we get started. Yeah, cool. Right. Okay, so the plan going forward, I'll run you through the spec and we'll go through each individual item that there is on the exam spec that you have to complete for the exam. We'll do some dodgy drawings and some kind of working out, and then I've got some questions that we can kind of finish off if you want to finish off with that. And if you have any questions, then chuck them in the chat window over on the right hand side as we go. And that's basically how this is going to work. And then this will be available online afterwards if you want to watch it back. So we'll start at the top. We're going to go over the fundamentals of the network, starting at what a computer network is at the top of the screen, this one here. So if you get asked that question in the exam, a computer network is simply two or more devices connected together to share resources or content with each other. So this could be, let's say, sharing a printer or sharing files or sharing something like that. Key thing is saying two or more devices, and then that they're connected together to share resources. That's the first bit. And that's literally what a computer network is. It says, describe the benefits and risks of the computer network. So what it means in that is you've got to compare this with just having a standalone PC that you can just use by itself. Now, obviously, the first advantage of having a computer connected to another computer is the fact that you can access the internet. The internet won't exist without having one or more devices connected together. If you just have a single PC, you can only use that for sort of word processing or creating things. You can't access anything on the internet. So that's one of the advantages of connecting to a network. Second advantage of connecting to a network is the fact, like we said, you can share resources with each other. So you can connect to things like a server. And a server is just a load of hard drives somewhere else away from your PC, maybe in the cloud, that your PC can connect to, and it can share files and access files. If you think about it in terms of school as well, the school system, you have loads of PCs all the way around the outside of rooms, and you can connect to the server downstairs, which will then have all of your files on. So the fact that you can have you can log on to any computer in the school and you can still access the same files, that's a really useful tool as well. However, the disadvantage of it, as it says there, you've got to describe the risks of a computer network. One of the risks is the fact that obviously if you get something on the network like a virus or a piece of malware, it can spread really easily across multiple different places. You've also got the problem of the fact that if you don't want to share your resources, you've got to make sure that they're locked down a lot better than just having it on your own personal PC. So for example, if you had a folder on your PC and it was on a network, you wouldn't want to share that with other people. So you need to keep that nice and secure. Main sort of disadvantage is the fact that obviously you don't want to spread things across the network. Some other disadvantages of having a network, although you'd have a network in your house and you don't have to manage it, if you have a really big network like our school network, where you've got multiple or hundreds of PCs, you're going to need somebody to manage that. And that's usually called like a network infrastructure engineer or a network manager, whose job is just to look after and make sure that the network runs at its full speed. Now, obviously, having one of those, it will cost money as well, because you need the people to be able to run your network. Whereas if you just have a load of standalone PCs, you don't need those people. So another disadvantage could be the cost. You've got another cost of running all the cabling and all the Wi-Fi or Ethernet cables or fiber or anything like that. So that is another disadvantage as well. Cool. For anybody that's just joined us, like I said, the way this is going to work, I'm going to run you through the spec and go through like each individual point to make sure you're happy on each of these different areas. If you've got questions and things, drop them in the chat window on the right hand side and we can kind of answer them as we go. Otherwise, I'll just keep going and then we'll get onto some questions at the end that I've printed off. And then if there's anything else you want, then we'll go from there. Otherwise, we'll just keep running through. So we've done what a computer network is. We've said it's 2 or more devices connected together to share resources over the internet. Sorry, not over the internet, to share resources between each other. And then we talked about the benefits and the risks of having a computer network. Obviously, I think the benefits outweigh the risks, but you can justify that in your answers. Describe the main types of computer network, including a PAN, a LAN, and a WAN. And you'll see down the right-hand side of here, it kind of gives you loads of different meanings between PANs, LANs, and WANs, and all that sort of stuff. But we'll go through each of those individually now for you. So first one you've got is a PAN. And obviously not like a frying pan, like I've always said, but if you've got, let's say, your own network and you have your phone, you might want to connect your phone to your device. And there's a couple of different ways you can do that. You can either use Bluetooth, or you can use something like a personal hotspot, but stick with Bluetooth. It's probably the easiest one to remember. So a PAN is where you're connecting, it's a personal area network, P being personal. So it's where you connect one of your personal devices to another one of your personal devices to share network or files or something like that. If we then move up inside, you've then got a LAN, and the LAN stands for local area network. So local is a local area such as, let's say, like a school or even your house or somewhere sort of possibly under the same sort of roof that you can kind of keep all the devices in-house. The main way to sort of differentiate between LANs and the next sort of size up is the fact that you have a device called a router. Might look like the wireless router in your house, and all those devices connect to that router before it's then bridged into the outside world. The LAN network is then therefore everything that connects to that one router before it reaches the outside world. The key thing with the LAN is the fact that LAN is local, so it's on a smaller scale. It might still be something like a school where there's 300-400 PCs, but it's not a massive scale. And then the last one is your WAN, and W stands for wide, so it's a wide area network. And that might mean that you've got loads of mini networks or loads of networks that connect together over a bigger network area. So let's say, for example, it could be 2 offices connecting together. This is Office 1 and this is Office 2. And they share files and devices and things between each other. They'll each have a little router on their networks, and they'll communicate in that way. But also a WAN could also technically be the internet, because the internet is loads and loads of networks. So your home network connected to your school network, connected to a business network, all connected together to communicate with each other. So the biggest type of WAN is the internet. Remember, don't get the internet and the World Wide Web confused with each other. The internet is not the World Wide Web. The internet is a load of LANs connected together, or a network, the biggest network that you can, joining things together. The World Wide Web is to do with websites and building, sort of accessing websites and files and all of that sort of stuff. Usually access the World Wide Web through a browser. So don't get them confused. We're talking about the internet. The internet is to do with networking and wide area networks. So as you can see here, we'll just drop down that. PAN, only Bluetooth needs to be considered, which we've kind of gone over. LAN, they cover a relatively small geographical area. And they're often owned or controlled or managed by a single person or organization. So we've either got the school network or your home network. You kind of manage that, and that's within your own area. Then a WAN is the biggest, the internet is the biggest example of a WAN, and we know that they usually cover a wide geographical area. They're also under some sort of collective or distributed ownership. So it might be 2 different offices or 2 different organizations. So boys' school and girls' school and the Priory could all be connected together, but they're all owned by separate people, and they all connect in that way. Okay, understand that networks can be wired or wireless, and discuss the benefits and risks of wired and wireless. And it says over here, know that wired networks can use different types of cables such as fiber and copper, and when each of these would be appropriate. So we've got two different ways of communicating across a network, as it says, either wired or wireless. So a wired network, you've got technically 2 different types of wired network between 2 PCs, or between 2 network interfaces or something like that. So your first one is an Ethernet or copper cable, and that's generally used in connecting devices together. So it might be in your house, you might connect your Xbox or PlayStation to your router, and everywhere like that. And that would be probably done over an Ethernet or copper cable. Your other alternative is using light. I'm going to draw it using this. And using light is called fiber optic. And that's usually tends to be between like servers or switches and things, and other servers and switches, rather than between PC and PC. And that's because it's quite expensive compared to Ethernet. Ethernet is quite cheap. You can run that over long distances and it doesn't cost too much, whereas fiber is quite expensive. However, fiber is better if you're sending lots of data and you're sending it over a longer distance and you want it to go faster, because actually it travels at the speed of light compared to the copper cable, which is to do with like the electrical signals or pulses. So you want to use things like fiber if you're transferring data between a switch and a switch, or between a router and a router, or over the internet or something like that. And that will be from the hubs outside your house. So those green boxes that you see on the road, the green cabinets that you've got, they're usually connected between fiber and fiber, just so you get the right speeds. But the internet that you've got in your house is usually done by Ethernet and copper. Inside your house as well, or inside the school or inside a network, you've also got the chance of having Wi-Fi, and your Wi-Fi connection will allow you to connect to your laptops or your phones and things, and it will provide a wireless connection over radio waves to allow it to have a communication. There are two bands. You don't necessarily need to know these in too much detail, but you've got 2.4 gigahertz and you've got 5 gigahertz, and different speeds and different ranges and all sorts of different things like that. But you just need to know that you've got wireless and you've got some different types of wired connection over here. So differences between your wired and wireless. So some of the advantages, obviously, this is portable to start off with. That's the idea behind wireless. You don't have to use any wires to be able to connect to it. And obviously your phone or your laptop or anything like that, it's much better to not have any wires to connect them up to something. Whereas your wired and your sort of fiber, you're obviously going to have to wire them in to your network. So although this is good and this is more reliable sometimes, so this is reliable, that's an advantage. The fact that you've got that kind of fixed communication points between two areas. So it might be that if you want a more reliable, possibly faster connection, but you can't always say faster, because Wi-Fi can be faster and they're getting quicker and quicker, but definitely a more reliable connection that doesn't drop as many packets between sort of your devices, then you want to look at your wired connection, whereas wireless, like I said, is more portable. In terms of cost, doesn't necessarily matter. I wouldn't necessarily say one is more expensive than the other. Obviously, you've got more cabling over this side, but then you have to buy different equipment to make sure things are connected to wireless. Nowadays, most devices come with a wireless card in them. Sometimes they didn't in the past, and you had to buy wireless dongles and things to connect them to the internet, which would have cost more money. Fiber obviously is more expensive than copper and Ethernet cable, but Ethernet cable is still pretty cheap and won't be too much. If you're going to say one's more costly than the other, it tends to be wired is now more costly, because you've got to put in different cables and boxes and connectors and things to make that work. So wireless is also more or easier to install as well, because you can just bring along a new device and you can just hook it up to your Wi-Fi, whereas with the wired connection, you've got to put in those extra wires and things to connect everything together. So that could be another advantage and disadvantage as well. Risks and benefits, sort of your risk, potentially your wireless is easier to hack into. People can join a wireless network, especially if it's an open wireless network, without any protection. So protection like WPA2 and all that sort of stuff, where you put in a passcode to connect to it. If that's not there, or if you're using one that is no longer secure, then wireless could be a little bit more dangerous. Whereas wired, you can connect and you've got that cable straight away. And unless you're connected via that cable, there is no other way to connect to that that network. So that can be more secure. Okay, that is understand that networks can be wired or wireless. So two different ways you can connect. You've got fiber and copper cable. So you've got the two different types of cable we talked about, and then some of the benefits and risks. Okay, I'll explain the two common network topologies. So you need to know two topologies for computer science GCSE. One is called star and one is called ring. So if we go into here, so your star network doesn't necessarily look like a star, but that's probably an easier way to remember it if you can. Let me change color pen. So if you've got this central node or device, so this could be something like a router or a switch or a hub or a server or anything in the middle here, that will connect out, and then you can create your star out from the middle there. On the outside of the star, you then have your devices that you would then connect to your central node, and this is your star network. Simply allows communication directly back to the router. We'll talk about the advantages and disadvantages of each in a minute. I think it says draw it and explain the differences. Yeah, we'll do that in a minute. Your other type is called a bus, and a bus is a single cable that the devices connect into. So there's my PC again, and there's my PC again. Put a couple more in. So last year they had a question on the exam that asked you to draw a bus and a star. So now you've got a bus and a star with some end devices. And these here are end devices. They're things that connect to the network. It could be a computer, it could be a laptop, it could be any of those. But they're the ones you sort of need to know. So you've got your central cable that everything connects into, and the devices then can communicate with each other. Both these are acceptable ways of communication, but they have their advantages and disadvantages. Just seeing the question, what about ring? You don't need to know your ring topology for your computer science exam anymore. It used to be that you had to, but you don't need to know that going forward. So it saves you knowing another one and knowing advantages and disadvantages of those. These are the two main ones you need to know. Okay, going forward, router. So, sorry, this one's star. Let me write star up here. And this one's bus. So your star topology, some of the advantages of your star topology, which are kind of the negatives of the bus, so you can kind of compare them to each other. But your star has individual cables back to your central node or central device that allows this communication to be nice and secure, and nothing else can read into that communication. It also means that you get less collisions. Because you've got one form of communication, and technically that can make it faster as well, because you don't have any sort of bandwidth issues where something is communicating lots and taking up a lot of that bandwidth. So less collisions, more secure. However, it can be more expensive because you have to have all of these individual lines, which if you're running them back to a central node like a switch, they can run for a long distance to get back to there. So that can be quite expensive. This one down here then, the disadvantages are obviously if you're sending a data packet between computers, actually that data packet ends up being sent to all the computers to try and see which one it needs to go to. So actually your data is less secure because that packet of data is being transferred across your network. Also, it relies on having this central cable, and if you break the central cable, if the central cable gets damaged, or if there's too much communication going on, this central cable will then become useless and you'll lose your connection between your different devices. However, the advantage of a bus, like we said here, this one's expensive, so this one is less expensive because you've got less cabling to run. And that's probably the key advantages and disadvantages between them. There are other advantages and disadvantages, and you can go and look some of those up. But they're the sort of key ones that you could sort of try and remember. As it says here, explain the difference between the two. You should be able to draw the topology. This is a topology, a drawing of how the network looks, and explain the differences between the two topologies. We've just done that. You should also be able to select the most appropriate topology for a given scenario. Okay, so this topology ideally would be more suitable in a small business or where you might have 2 or 3 computers that you might want to connect to a network. This is more suitable for where you've got a larger amount of devices, where you want to keep connecting them to the network that maybe require a lot more powering, or a lot more data processing, and they need that access back to the router a little bit easier. That you can also connect this to like servers and things like that, and then out to wider networks. You can do the same with the bus. But the bus is suited for a smaller business or a smaller organization. As long as you justify your points and explain which one you'd use and why, that will probably be acceptable in the exam. Okay. So next one underneath, define the term network protocol. And actually, there is a list of protocols on the next page that we're going to go over. But a network protocol is just basically a set of rules. We've got the word protocol in there that you might remember, or you might have heard before, when somebody says there's protocols for doing this, maybe in the army or something like that. There are protocols and rules that set up the communication or decide the communication between two devices. Communication between two devices. And usually it's sort of a 2-mark answer. So it's the rules to set up the communication. That's the way you break down the answer to make sure you've got both. So that's what a topology is. That's what a protocol is, sorry. Protocol. So a network protocol is the communication between two devices. You need to know about 10 different protocols. So we're going to list them out now, and I'm going to break them down into different categories when we do this. So the first ones I would always sort of start with are HTTP, HTTPS, and FTP. I'm going to band them all together in there. Another couple are UDP, TCP, and IP, and I'll band those all together in there. Then you've got let's do it in blue, this blue, SMTP and IMAP. There's 2 more in there. So we've got 3, 6, 7, 8, and then there's 2 more to go. And your 2 last ones are Wi-Fi and Ethernet. And they are the 10 that you need to know. The reason why I've banded these all together, they're not to do with the levels of the TCP/IP model. We'll come on to that in a minute. They're more to do with kind of what they do or what they're used for. So you've got these 2 down here to start off with. These are 2 protocols that are actually, they've got lots of different smaller protocols within them, but there is a way of setting up a communication or dealing with the medium that you're going to send your packets over the network. So you can send it via Wi-Fi or you can send it via Ethernet when it gets down to the lowest level, when it gets down to bits. And they're the 2 that you can put under that sort of header. And it says under here, students should know, or students should understand, that Ethernet is a family of related protocols rather than a single protocol. Wi-Fi is also a family of related protocols rather than a single protocol. So these ones over here are single protocols, but these ones are sort of a family of them. And they set up how 2 devices will talk to each other, which sort of way they'll talk to each other. You also need to know that Wi-Fi is a trademark or sort of a brand, and actually the generic term for this is called a WLAN, or a wireless LAN. That's just something to know, rather than if they ask you a weird question about, well, what is Wi-Fi actually should be known as, a generic term, then you can put WLAN in there instead. So I banded those 2 together for that reason. Then you've got SMTP and IMAP. And SMTP and IMAP are both to do with your email system. The difference between the 2, SMTP is to do with sending mail over the internet. IMAP is for looking at a server. I'm going to draw some eyes. Looking at a mail server to see what has arrived in. So it's almost like receiving the email. And that's the difference between the 2. But they're both to do with email. Then you've got UDP, TCP, and IP. And we'll look at UDP and TCP in a minute when we come to the TCP/IP model. But all of these 4, I would say, are to do with how your packets of data, so I'll just draw that, are communicated over a network. So you can set up the transmission or in the transport layer. We're going to look at those in a minute. And in the internet layer, we use the IP to be able to make sure our packets are sent successfully over a network. And then the last 3 up this end are HTTP, HTTPS, and FTP. And they deal with things at the application layer, whether that's a website using HTTP or HTTPS, or uploading files, or file, something like that. That's file. Files to the internet onto a server. And it's to do with how you might read or receive files from a server. So HTTP and HTTPS are how you access HTML files from the internet and read those. S meaning secure, and it's then to do with encryption. It means that the pages are encrypted. FTP is to do with the file transfer, so it's where you upload files to a server so that you can then read them or access them. So all of these are to do with how you read and write files and websites. So that's sort of your introduction to the 10 different protocols that you'll need to know for the exam. And if you look down this list, it says you need to know about these 10. So Ethernet and Wi-Fi, we talked about. TCP, which stands for Transmission Control Protocol. UDP, which stands for User Datagram Protocol. And IP, which stands for Internet Protocol, are these ones in here to do with the network and how things are transferred and communicated. You've got HTTP, HTTPS, and FTP, which are the ones down here. Hypertext Transfer Protocol and File Transfer Protocol. And then you've got the email ones, which are SMTP and IMAP. So you've got Simple Mail Transfer Protocol and Internet Message Access Protocol. And although it's worth sort of remembering those names, it's more important to remember what they do and where they sit within the TCP IP model, which we'll go into in a minute. Students should know that each protocol is used for, and then it says about the secure network. So we've kind of gone under those, and you know a little bit about each of those now and what they do. You might want to look into these a little bit more and come up with like maybe a 1 or 2 mark answer to explain what each of these do in your own words to make sure you get the full marks if a question came up along those lines. We're gonna kind of skip past the network security and that bit, when we'll come back to that in a minute, and we're going to skip down to the TCP/IP model because it fits in quite nicely with these protocols. And I know that we've done this quite recently, or we're going to do it quite recently, depending on which year 11 group you're in, and if you're in year 10, you did it today. But I'm going to break down the TCP/IP model in a little bit of detail so that you know what each of the layers do and how the protocols work with each of the different layers. So your 4 layers of the TCP/IP model, starting at the top layer, starts with the application layer. Then the next layer underneath that, I'll do it in a different color pen, is your transport layer. Then the one underneath that is your internet layer, formerly known as your network layer and sometimes misunderstood as network layer, but we're going to call it the internet layer, and that's how it's known as in the exam. And then the last layer is called the link layer, or the data link layer, as we call it. And they are your 4 layers of the TCP. I'll go right on the top in a different color pen. TCP IP model. And they're the 4 you need to know. You need to remember those, and you need to remember the order of them as well. So you've got to remember A, T, I, L, and come up with some sort of acronym or something to remember which order those are in. Let's break down what happens in each of these different layers. If we look at the spec and see what it says you need to know about those 4 layers. You need to understand where they operate, these different protocols, which we'll go over. You need to name the layers, and you need to kind of talk about what happens at each of the different layers. So application layer. This is where your applications, so your things like your browser or your email client or programs operate. So they're the ones sort of setting up the communication and deciding what you need to do. So let's say you're going to Google, or let's say you're sending an email. You'll make that decision at the application layer. Use different protocols at this layer. So you use HTTP, use HTTPS, and use FTP, because they're the ones we talked about earlier that allow this communication with sort of your browser or with files. So I'll put the file back in here as well. File back in there. And you also then have the email ones as well. So you have SMTP and IMAP. So all of those different protocols work at the application layer. Those once the application has decided what it's doing, or you're sending a message, or you're visiting a browser, it'll then be passed down to the transport layer. And at the transport layer, that's where we set up the communication between the 2 hosts. So 2 hosts are like a PC and a server, let's say. We need to decide on how that communication is going to happen between those 2. So if you've got the transport, so at the transport layer, sorry, you then decide sort of the language and the size of the packets and how you're going to get those packets from one end to the other. So we've got, let's say we've got our email. We're going to break that email down into packets of data. 1, 2, 3, 4. So we've got our packets. So we've decided the size of our packets. And now we need to decide how those packets are going to be sent. And we have 2 options here. We have TCP and we have UDP. Difference between TCP and UDP, I'm just going to break down to another sheet. So TCP, let's imagine we've got a client, something like a PC and a server. TCP will want to make sure that, let's say, the email gets from this computer here and gets across the network and gets into this server. So TCP will set up a communication, and it will do a handshake between the server and the client, and it will make a 3-way handshake to ensure to ensure that there is a communication between these, and there is an open communication, and all the packets have been received. If the packets haven't been received, then it will say send it to me again, or return the data or something like that. Because actually, if we're sending an email to somebody, we need the whole email to get there. We can't be dealing with the fact that we've only got half an email arriving. It needs to have the whole thing to arrive successfully. Your other option is UDP, and that's more useful. Let's say when we're streaming something across the internet, or you have your FaceTime or something like that, you're trying to communicate with somebody via servers and across the internet. There's your server again. What we're going to do now is we're just going to send this data across the internet and hope it arrives at the other end. So we're going to check. We're not going to do any checks, sorry, and we're not going to know whether they're all going to arrive or not. So that's, like I said, more useful when you're streaming, or when you're using things like Skype or FaceTime or anything like that, where you just need to get the packets from one end to another as quick as you can. This is obviously a tiny bit slow. We're not talking massively slow, but this one's a tiny bit slower. And if we had to wait for every packet in a stream, it would slow everything down and you wouldn't have that instant connection. Whereas with an email, you don't need it instantly. You need to make sure it's all there successfully. So that's your two options, TCP and UDP. So that's why at the transport layer, you agree your communication and you break down your packets into size to make sure it goes out at the other end. So then we go down to the internet layer. And we now have our packets. Our packets have been passed down to our internet layer. And at our internet layer, we are going to use the internet protocol. And the internet protocol is like an address. 172.133.75.23, whatever it is. And at the internet layer, we address these packets with our IP addresses of where it's going to go to, and where it's going to go from, and it gets ready to route the packet across the network. So it's getting ready to send it and getting ready to push it out, basically. So it routes it across the network and sets up our IP addresses. So it addresses the network. Addresses, let's go for addresses. Addresses them to make sure they can get to the other end successfully. Addresses then packages. So yeah, it's packaged it and routes it ready for transmission. That's quite a nice word as well. Transmission. So getting it ready to go, basically. Once we've got down to the internet layer, we're then going to pass it down to our link layer. And our link layer is important because that's what actually does the sending across the network. And as Mr. Wilson said in year 10, and what I've always told the year 11s, down here you've got a little man, and his name is called Nick. And Nick is in charge of getting rid of the data and sending it across the network. Now, a Nick isn't actually a person. A NIC is a network interface card. And you can either have a wireless internet card, or you can have an Ethernet NIC, network interface card, that allows your data to be sent in bits across the network. So we need to have a medium, and whether that is copper or fiber or Wi-Fi, or however we're sending that across. At this layer, we're using the Wi-Fi and the Ethernet protocols. I'll put Ethernet over here as well, to make sure these things are sent across the network, and we have our bits transmitted across the network. We've got device drivers in here, going back to our hardware. Device drivers, they're the things that allow communication between these bits that go across the network. And we've got then our zeros and ones that are transmitted across the network to wherever we're trying to send them to. NIC is branded with something called a MAC address. And the MAC address is unique to this device that is sending it. So this all happens in one device. So this device here, let's say this is a laptop or a phone, this will have a NIC for its Wi-Fi sending it, and that MAC address is a hexadecimal address, if you want to know that, which identifies this device, and it is unique. It doesn't exist anywhere else in the world, which means that actually if you're sending something to somebody, you're going to get returned. It's going to come back to you because it's labeled up with this unique MAC address to make sure that communication happens successfully. So it says here, let's just recap. Application layer, this is where the network applications such as web browsers and email programs operate. Transport layer, this sets up the communication between two hosts. and they agree on the language and the size of the packets. We've got the internet layer, addresses the packets for transmission and routes the packets across a network. And then we've got the link layer, or the data link layer, which is where the network hardware, such as the NIC, is located. And the OS drivers also sit there. Operating system drivers also sit here. And you've got your MAC address, and you've got NIC down here that sends it out across the network in bits. And that's sort of the overview of the TCP/IP model and the different protocols that take place at each layer. HTTP up to the packet size, and HTTP, FTP, TCP, UDP, and then IP are your main protocols that happen at these different layers. I don't think there's much else to say about the TCP/IP model. Application layer, transport layer, internet layer, link layer, and all the different things that happen at the different layers. That's about it. The only thing that you just might want to know a little bit of background about is how this then gets to the other end and transmits successfully. So if you've got your, I'll just go write these out all in blue, application layer, and then you've got your transport layer, and then it transmits it down to your internet layer, and then it packages it up and sends it out using the link layer. That data is then sent across your medium, so over your Wi-Fi or over your Ethernet connection or fiber connection, until it reaches another router or reaches another device. So this is your router here. At that router, it will then go back up to the internet layer, where it will make a decision about the IP address and check to see where it is or where it isn't. And then it will then pass it back down and back out again across the network until it reaches the right location with the right IP address. And then it will pass it back up to the application layer so it can be dealt with successfully, whether that's on a browser or fetching a web page or whatever it is. The data is then passed back down and then back across the network to get back to your application at the other end. So let's say, for example, you take a picture on the internet, you take a picture on Instagram, and you want to send that to somebody else. You want to upload it to the server, the Instagram server, so other people can see it. It would then package that up ready for transmission across the internet, turn it back into bits, and we know how bits work with images, hopefully if you've done the data representation stuff. So turning it into noughts and ones, transmits that across, tries to find the Instagram server. When it finds the Instagram server, it will then take the packets, put the packets back together again, and take it back up to the application layer and form it ready in their server so that actually that picture is then accessible to other people. Then other people will then try and access it and would access that server in the same way, and that server will then return the picture back to the application that you're trying to view it on. So that'd be on the Instagram app, if somebody else is then looking at it in that way. And that's basically how the TCP/IP model works. Although it doesn't necessarily say that in the spec, it's more focused on what happens at each of the different layers and how things happen at the different layers. But it's worth knowing that at this one, that's where the router sits in there. And there is the switches operate at this layer as well, in case you need any detail about sort of the hardware and where that works. So that's the TCP/IP model in a little bit of detail, so you know what happens at each of those different layers. Okay, so if we go back to the spec, we've done all of that up to cybersecurity, and we're not going to do cybersecurity in this one. We're going to now have a look and see what else is left on the spec. So we've got understand the need and importance for network security. Now, obviously, that's a little bit of a silly sort of point to make, but it is kind of useful because a lot of the time we forget how easy it is to access something over a network. And if we go back to the original sheet where we were talking right back at the beginning, when we've got two or more computers connected together, it's very easy to start sharing things and not realize that other people can then start having access to your devices and get access to your files and printers and all of that sort of stuff. There's lots of people on the internet that make jokes of sending things to protected printers that just start randomly printing out lots of different random sheets and all that sort of stuff. So we need to make sure that we're protecting our network, because we can have things like hacking, or people can take over our network or steal our information and steal our identities and things like that. A lot of that stuff comes under cybersecurity as well, but we need to make sure our network is secure. And there are 4 different ways that it talks about in the spec that you can use to make your network secure. And they're authentication, encryption, firewall, and MAC addressing. MAC address filtering. So don't have to go into too much detail under this one, but it's well worth going into a little bit of detail in some of these. So authentication is where you have, let's say, your files on your computer, and you want to work out who has access to those and who shouldn't have access to those. And if you've got these on your computer, you need to be able to set up a way of authenticating a person to see whether they can have access to them or not. And this computer could be a server or something else. It doesn't have to just be a PC. So that person, how can you authenticate that they are who they say they are? Because that could be a baddie that's trying to, or somebody that's trying to hack into your system and trying to get authentication by saying, look at me, I'm the right person. So there's a few different ways you can authenticate. Most common way is by using a strong password or a password and username, because most of the time people use username and passwords to access their server. We use them in school a lot. That's the first thing you log into to access your files. You have your own username and password, and that allows you access to certain parts of the network. The other way is having user permissions. So we've got multiple different users in a network. All of them should have access to their correct files and their correct network. So let's say, for example, you have a teacher. They might have access to teacher things. They might also have access to student things as well. The student should only have access to student things, but you've got your administrator over here. Your administrator will have access to administrator rights, it would have access to teacher rights, and it would have access to student rights as well. So depending on who you are, you need different access rights to access different parts of your network. So you've got access rights, passwords are good as well. You can also talk about things like biometrics. Biometrics are things like using your eyes or handprints. I'm going to draw a very dodgy hand now. 4 fingers, that's right. Handprints or thumbprints or anything like that to make sure that you have access to that data. Biometrics are good because they're related to the person, and that kind of identifies them as the correct person. They can be spoofed sometimes, but that is a way of authenticating your you are the right person to access those files as well. You've got things like two-factor authentication, which we've talked about in the past. So where you've got your phone and it gives you a code 3FB72 or whatever. You type that into your computer when you try and log in, and once you've logged in using your username and password, it then asks you for your two-factor authentication, and that's because that's come through your phone. That is a very bad phone. I can't even draw a phone. I was doing all right with my drawings, but you've got your phone. That appears on your phone, and then that's where you then use that to be able to access or to log into something like a website or a file or something like Twitter or Instagram. And just it helps prove that if you own the phone because you're currently holding the phone, then that means that it must be you when you're trying to access these files. So you've got two-factor authentication, biometrics, access rights, passwords. They're usually some of the easiest ones to mention when you're talking about authentication. Okay, encryption. Encryption, put simply, and you might want to go into a little bit more detail in this, and it does appear a little bit, I think, in cybersecurity. But if we've got a file, let's say we're trying to transmit across the internet and we want to send it to somebody else so they have access to it, we might want to make sure that when it's sent across the network, across our medium, that it's not accessible by anybody else. So we're going to turn that file and we're going to turn it into something that is unreadable, but we can get back at the other side once we've sent it through our network and back through to our other end. The reason we do that is that if we have a man in the middle attack or somebody that's trying to access our files, they'll look at this and they'll go, we have no idea what that is. Now, there's different ways you can do authentication. You can do encryption, but some of the most simplest ways are just by having a key that is used at one end. I'll draw a bad key. Oh, that's a very bad key. That's not too bad. You have a key at this end that that everyone has, like a public and private key that they can use and that they can share, that allows you to lock and unlock your different files and be able to turn this sort of mess into something that is a little bit more readable and a little bit more understandable. That key will also exist at the other end in some sort of form. Oh, that is a very bad key. And they too, the other person will have these keys at their end. Whenever you log into WhatsApp or you start a WhatsApp conversation, it will say you have end-to-end encryption, is what it says, end-to-end encryption. And what that means is Oh, that's really weird in capital letters. Encrypt. I think I've got that right. Yep. Encryption. End-to-end encryption. And what that means is everything, when you send that message at this end, it's then sent across the network and actually it arrives at the other end, and nobody in between will have read your messages, not even the Prime Minister or anybody like that, hopefully. And that's why sort of the governments and things want to ban end-to-end encryption, because they want to be able to see messages that go on between two people. So encryption is a way of disguising or mixing up a message to be able to prevent a man in the middle or somebody in the middle, doesn't have to be a man, an attacker in the middle that can access your data. Okay, so that's simply what encryption is. You might want to go into a little bit more detail, like I said, and look a little bit more up about that. The third one that you can have a choice of, let me find a bit of paper, is firewalls. So firewalls are often depicted as a wall with loads of bricks in, and it's like, oh, this is a wall on fire, etc. Not a wall on fire. Don't make that mistake. So it is simply a way, is either a device, so it can be on your router, or it can be part of your software, so your operating system. And Windows has this built in, Mac has it built in, but also your Virgin router, Virgin Media router, or BT will also have this built in, and lots of different devices have them all automatically built in, so you can use them. What it allows to do is, let's say you have a packet of data that you want to transmit to somebody else onto their network. This is your packet. Your firewall gets in the way and sits here, and it says, do I allow that packet in or not? And it allows your network to be able to prevent malicious packets, bad packets, from getting into your network. And if it is a bad packet, it will drop that packet and it will say, no, you're not allowed in. And that packet is then sort of deleted or got rid of. That prevents things like malicious packets or DDoS attacks, which is where you get a denial of service attack, where loads and loads of packets are sent at once from a network that doesn't have a connection with your computer, and all of a sudden this computer's then got loads and loads of packets hitting it. Your firewall will hopefully make sort of a judgment and say, actually, this doesn't make sense, I'm going to drop it. There's a few different ways you can do firewalls and make firewalls work, and there's one called stateless, and there's one called stateful, I think the two are, but that's a little bit more detail than you need to go in for GCSE. All you need to know is the fact that it prevents malicious packets from accessing a network at the operating system level or at the router level by filtering. Filtering is quite a nice word. Filtering out the malicious packets before they reach your computer. And then the last one that you need to mention when you're talking about security of a network, I'm running out of paper, is MAC address filtering. So we talked before, actually, let me get my picture up of the TCP IP model. We've got the MAC address. And the MAC address, like we said, is unique to this device that's communicating with the network. So if we know the MAC address of a communication, let's say we have our PC, this one will have a MAC address that is unique. A MAC address. A Mac isn't Apple Mac, by the way. A Mac is, I can't remember what it stands for, but every device has a MAC address. So the MAC address is there to communicate, and it's unique to this device. So therefore, if we have our router, let's say, for example, this router will allow communication in and out to that MAC address. But what it could also say is, actually, this MAC address is now no longer wanted on our network, and it will then drop that device and prevent that device from accessing the network based on its MAC address, because the MAC address, like we said, is unique to that device. It will still allow this device over here to communicate, because this one has a different MAC address, so that one's fine, but this one here, you are no longer allowed. And there's two ways you can do it. You can either whitelist or blacklist. Whitelist means you've got a load of PCs on your network, and therefore that one, and that one with those MAC addresses are all allowed, and anything else that connects to our network is not allowed, because they haven't been whitelisted. Whitelisted means, okay, like writing a list of the good ones that are allowed. The opposite way is to allow everything access, but then when you get like a malicious one or someone you don't want access to your network, you then blacklist them. And that means you just kind of block them if they're not needed on your network. So it could be that they're trying to hack into you or something like that, or you just want to block your brother or sister off the network. You can log into your router, and then you can blacklist that device, whether that's a PC or whether it's a phone, or whatever it is, you can say, actually, no, we don't want those devices on our network. And that's what blacklisting and whitelisting is of a network, to do with MAC address filtering. MAC address filtering. MAC address filter. Okay, so if we look at what it says in terms of authentication, encryption, firewall, MAC address filtering. So that's they're the 4 different methods of network security. Someone's just asked, are black and white box cybersecurity? They are. White and black box penetration testing are to do with cybersecurity, but you can whitelist and blacklist MAC addresses in a network to whether they can connect or whether they can or can't connect. That's the difference between the two. So whitelisting and blacklisting is to do with MAC address filtering, whereas white box and black box penetration testing we will do when we come on to cybersecurity a bit later, when we do one of these, and when you do the revision. They are to do with cybersecurity. Don't get them confused. Although they tend to sort of work in the same ways. White boxing, again, people that you want on your network, people that you know. Blacklisting, more malicious people on an outside network trying to get in. They kind of overlap slightly, and that's why they take the same name, but that's to do with MAC address filtering instead. To be honest, I don't think you need to know about whitelisting or blacklisting. If you look at the spec, it doesn't say that in it. But it's always worth, when you're talking about MAC address filtering, it will give you more to talk about in terms of what you can block and what you can allow based on whether you allow their MAC address, not their IP address. Do we need to know about coaxial cables and terminators and stuff? Nope. Literally in the spec, all it asks are fiber. Let me get the thing back here. Here you go. This is what it says in your spec. It says, know that wired can use different types of cables such as fiber and copper, which we've done, and we've done the advantages and disadvantages of fiber and copper, and when each would be appropriate. So the different ones would be appropriate. Obviously, fiber, when you've got a faster connection over a longer distance, speed of light. Copper, where you need to run multiple devices, maybe on a home network or something like that, is cheaper, and it's easier to run different cables. And that is your basic fundamentals to cybersecurity, and that is everything you need to know for your GCSE. I've lost the other sheet. There it is. And that's the different areas that you need to know for networking. Technically, we've got about 9 minutes left, because I said we'll go till 9 o'clock. If anybody has any questions, then this is your time to shout in the chat, and I will answer them for you. I'm going to put up some questions on the screen while I wait. If anybody's got any questions, chuck them in if you've got them. Otherwise, there's a few here. We can just kind of quickly go through. What is a computer network? Computer network is 2 devices connected together to share communication or share content, or I'll say this earlier, share devices, share access to resources, that sort of thing. Identify one reason why we use computer networks. Well, to be able to communicate with each other is a really good one. To be able to access the internet, that sort of thing. Identify and describe 2 risks of using computer networks. Well, we've got the risk of data spread, being hacked into, or viruses spreading. You've got disadvantage as well. It's going to cost money to get people to run your network for you. You'll have to have a network manager, especially in a bigger network. Match the descriptions. PAN is an individual person used on mobile devices. WAN is a large region, and LAN is a small region. State the largest example of a WAN. Well, we know that that's internet. State an example of a PAN. Well, it's Bluetooth. Identify the physical medium that's commonly used to connect devices to LAN. Well, we said actually that's Ethernet, or the copper cable. I would say if it's talking about physical medium, you can put both down, but copper cable is probably the best way to go. Devices are connected wirelessly via LAN. What's the name of family of protocols used? Well, the family of protocols we said was Wi-Fi. Identify the potential risk of using a Wi-Fi network. Again, you could put hacking in the box in there. People can hack into it. People can do things like packet sniffing, although we didn't talk about that. Would AirDrop be an example of a PAN? Technically, AirDrop would be an example of a PAN, but it's specific to Apple devices, and I know that they don't like branded things. So I would just stick with Bluetooth. Personal hotspot could also technically be an example of a PAN, but AirDrop actually uses different things like Bluetooth and Wi-Fi to be able to connect. Anyway, it's just Apple's way of doing it. 2 different types of topology. We know that one is a star and that one is a bus. Tick the boxes that apply for a star network. If one cable fails, none of the other computers can function. Well, we know that's not true, because a star can continue to function if one of the cables, no collisions can occur. Well, that is true, because actually no collisions can occur between the two devices, so that one is true. We'll go for that one. And it's 3 marks, so it's got to be 3. Cheap, there's not much cabling. Well, that's wrong because that one's cheaper. Switches are needed for communication around the network. Technically, that's where the switch would sit in there, in the star. So yeah, I think that one's going to be true. We'll have a look in a minute. Performance is dependent on a central computer. Well, yeah, we're going to be based off of this thing in here. So that one is true. Data is unnecessarily transferred across the network. Well, that's not true because data is only between 2 devices. So we know that switches are needed as well. So we know it's those 3. Whereas here, data is unnecessarily transmitted between different things. Explain how information is sent between computers on a bus network. Well, data is sent between one device and another device, but it's also sent to all the devices or end devices on the network to be able to find the device it's trying to connect to. So all the packets are sent across the network together. What is meant by network protocol? Well, we said the protocol is the rules to set up communication between 2 or more devices on the network. So it's the rules to set up the communication. Briefly describe which of these are the following protocols. So FTP, we said, was a file transfer protocol. So it's transmitting files from a client to a server. SMTP is the simple mail transfer protocol, which allows you to send emails. And the Ethernet is actually a family of protocols, we said, which allows you to transmit data across a copper cable successfully. The Hypertext Transfer Protocol is used for the transmission of web pages. Describe the difference between these two. Well, S stands for secure. So secure HTTPS allows you to transmit web pages using encryption and keeping that nice and secure. Using examples, state when HTTPS should be used. Well, HTTPS should be used for things like banking or shopping or wherever you're putting in personal data into the internet. And it's actually more commonly used now pretty much everywhere. You'll notice that Google uses it, YouTube, and everywhere should be using HTTPS. Networks can be made in a secure number of ways. State which security method is being described. You keep your network secure using a hardware or software application that monitors and controls incoming and outgoing traffic and acts as a barrier to ensure only authorized traffic can access the network. Well, that's a firewall. The security method involves scrambling data. That's encryption. Using this method allows verified people to access a network with passwords to prevent access. Well, that's authentication. One method of network is to only allow certain computers to be able to physically join the network. This is done by adding a unique identifier, MAC address, to a list. So that's MAC address filtering. Then the layers of the TCP/IP model. Well, the bottom layer there is data link layer. So this one is the internet layer. This one is the transport layer. And that means the top one is your application layer. Identify and describe the function of the transport layer. Well, let's go back to our diagram as it's here. The transport layer sets up the communication or agrees the communication between the host and a server or between the devices. And it agrees the packet size and whether it's going to use TCP or UDP for its communication methods. The TCP/IP model and the TCP protocol are used in the transport layer. State the alternative to the transport layer protocol. We've just done that, UDP. For each of the protocols, state which layer they operate in. IP layer, well, internet protocol works at the internet layer. HTTP works at the application layer. FTP works at the application layer as well. And TCP works at the transport layer. Networks are often only allow wired connections. Discuss why a large company may prefer to use a wired network connection over a wireless network connection. That's quite a big chunky question in there. But I'll be talking about things in there about the security of a wired connection. People can only physically connect to a network if they've got that cable and they've got that plugged in. Wireless can be unsecure, especially if you don't have a password to be able to access your wireless network. People can also do things like packet sniffing, like I said before, where they can look and they can see the packets that are going across the network. You also could talk about in here about the reliability of a wired network. Actually, if you've got a connection directly into a computer via a switch or a server, that's better. That's why all the PCs at school are wired connection. They've got a better reliability. There's less collisions if you've got loads and loads of devices on a wireless network. So let's say you've got the whole of an office building on wireless network, it's going to be slower. Whereas if you go back to that star topology, you can obviously remember that everything's got its own connection, its own dedicated line back to the switch or back to that central node. So there's a few different things that you can kind of talk about in that answer around sort of security and the advantages and disadvantages of wireless connection. And that takes us up to 9 o'clock. And that is the whole of networking. This will be online afterwards, or I'll put it on Google Classroom so you can access it and watch it again if you want. If there are any other questions, you can shout now. Otherwise, we are going to call it a day. And I will see some of you tomorrow. Any other questions? Last chance. Okie dokie, cool. And that's your hour. Hopefully that was useful. There's another one, I think, in a couple of weeks, I think, where we'll do I'll try and do one on each area of the spec. So you've definitely got each area of the spec in as much detail as you can, and you can watch these back at any time. If you've got any other questions, let me know in school or come and find me or whatever you need. Thanks for tuning in.